Hello, everyone. I hope you had a wonderful break and you're ready to this day's concurrent sessions. I want to welcome you all to the Enhancing Clinical Practice and Outcome streams of today's SNOMED CT Expo program. My name is Anne Randorf-Høyen, and I'm an implementation support specialist at SNOMED International, and I will be moderating the session today. So all questions will be answered at the conclusion of the presentation. And online attendees, you can please use the Q&A button to type your questions to the presenter. And for on-site attendees, you can use the microphone that will be provided. So just raise your hands and we'll give you the microphone. So now I'm pleased to introduce Christine Spisla from Deloitte, who will be presenting modeling in vitro diagnostic device data using the LOINC SNOMED CT collaboration extension, a path to success. So Christine, we are looking forward to your presentation, and you are online, so you're welcome.
Welcome, everyone. Today we will be talking about modeling in vitro device data using the SNOMED LOINC collaboration extension and the path to success that our team has worked on. So this presentation will build upon the presentation that we gave at the 2023 SNOMED Expo, where we introduced an integrated knowledge management environment to represent in vitro device data, along with the various data elements coming from multiple lab data standards. I'll also be sharing the outcomes of tests that we did using this model during the past two HL7 Connectathons. So in developing the knowledge management model, the first thing we need to do is we need to take a step back and look at the current state. And what we're going to do is we'll use the clinical statement that's in that upper part of the screen in the dark blue box. Using the analysis normal form or other forms of structured data or other data mining applications, we can leverage terminology codes for secondary uses of clinical data for interoperability, for research, for disease surveillance, and the like. But important lab data related to the lab results is missing in these codes and in this data. So let's take a look at the current state of our lab data. The COVID pandemic taught us a lot about the current state of our lab data. In the United States, the Food and Drug Administration, or the FDA, sponsored a study to look at a certain type of lab data and is to look at the accuracy of coding those lab test results to lab codes. And what they found was 42% of the time there was a mismatch, or the lab chose a different code that was recommended by authoritative sources. So what the FDA then did with LIVID, which is the LOINC in vitro device diagnostic data specification, LIVID gave the labs the test codes to use and to encode their lab data with. Now, this is specific to the COVID-19 tests, Lyme disease tests, the Mpox virus, and also the HIV virus. And they still found that there was a mismatch rate of 21%. So even when we're providing codes to the labs and telling them which codes to use, we're still finding discrepancies. And so what we did, we looked a little bit further, and using these LIVID codes, we took a little bit deeper dive, especially with COVID-19 tests. And we have, from the LOINC SNOMED collaboration, we selected one lab test, and we looked across the different lab in LIDR, in LIVID, excuse me, we looked across that one code. And if you look at the box in the bottom, in the table on the left side of your screen, you can see that same code is applied to different manufacturers, and those different manufacturers use different analyzers to analyze it. And if we continue looking to the right for specimen descriptions, we can see that different codes are being used to describe the different specimen containers that are being used. And even as we go across to the right side of the screen and we look at the lab descriptions for that same LOINC SNOMED collaboration code, we have different manufacturers who are using differing lab results. And so these differing lab results are impacting our ability for not only interoperability, but to share, compare, and aggregate that data for secondary uses. And notice, and again, I'm going to emphasize that all of these are represented with the same LOINC SNOMED collaboration code. So sorry. So what we're working toward is taking that disparate knowledge resources from authoritative lab sources that everyone is using, and we're putting them into an integrated knowledge environment. And we're harmonizing all these different resources so that we can create reliable knowledge from these lab results to be used for regulatory purposes, for the labs, for public health agencies, for disease monitoring, and then also for the IVD vendors themselves to understand how they can work with their labs without losing meaning for their data. So when we're expanding LIVID to LIDR, LIDR is providing more of this information, and we're trying to expand it past the diseases that I talked about earlier, which is COVID-19, Mpox, HIV, and Lyme disease. If we look at the left side of the screen and we're looking at taking all of those lab tests together that are using exactly the same code, and we're looking at the percent positivity of the lab results within a given population, we can see that without the unique identifier, we get a certain type of positivity. But when we start to dissect out these lab results by the unique device identifier, or that UID, we can see that the rate of positivity changes based on the lab tests that we're using from different manufacturers. But with LIDR, we're getting additional information because we're also getting that IVD, that device data, and that shows us that certain tests that are being integrated into this combined test result has less sensitivity to a newly discovered variant, which is giving us information why we're getting these various lab results and possibly negative, false negatives or false positive test results in a given population. So you can see as we're adding more of that IVD device data into our lab test results, we're getting more information. And with that additional information, we're getting more insight to the test results that we're seeing. So the Tinker model, let's take a look at the Tinker model again. And the Tinker model is similar to the SNOMED model. And so I want to walk you through it so that you understand what you're seeing. And it starts with the concept, and that concept represents that one thing in the world. And then the concept is described by patterns that help define that concept. And if you think about patterns similar to the defining attributes in SNOMED, it helps define, the different properties for that concept. And the semantics provide the values for those different patterns. And one semantic can only refer to one pattern, just like in SNOMED, and then that one pattern, though, can have many semantics that can populate it. And so this is how we harmonize, given our various terminology models. If we take this Tinker logical model for the harmonization, we can start to harmonize all these various terminology models coming from these various sources into one integrated knowledge environment. So let's take a little bit deeper dive in with that, and let's use a lab concept. So on the right side of the screen, we're going to use that urine homocysteine. And that urine homocysteine lab test has a unique identifier that comes from that terminology source, be it SNOMED or be it LOINC. And if we're putting it into our Tinker model, each of those UIDs aligns with that identifier in the identifier pattern. And that identifier pattern will also identify the source. Did it come from LOINC? Did it come from SNOMED? Or did it come from a third party, another one that's outside of that? And then it also provides that identifier value. And then the stated definition gives us that EL++ axiom. And then we look across to the right side of the screen, you can see that that LOINC code is still maintained and that SNOMED code is still maintained within that semantic, the SNOMED semantic and the LOINC semantic that populates the pattern that provides the definition for that concept. So hopefully you're starting to see how this all gets put together. And not only are we using for the UID, but we're also assigning device properties to these devices that are coming from LIDR. And if you look at the left side of your screen, some of these may be familiar because these are coming from LOINC. But then as we go across our screen, you can see that the instrument equipment also has a pattern, and we get that information coming from our vendors to populate the instrument equipment. And the same thing with our specimen collection device. And then as we continue to go across our screen here, across to the right side, we can see additional patterns that are being populated, and underneath we're seeing the different semantics that we're using to populate these different patterns that help describe that lab test and provide additional information that can be informative as we aggregate data for these secondary purposes. So now I get to do a little bit of show and tell, and this is the exciting part. What I want to show you is how these axioms that we're building in the integrated knowledge model are appearing and how they align with SNOMED and with LOINC and with the collaboration. So the first thing I'm going to show you here, this comes from the LOINC SNOMED collaboration. And I want to show you here how with this, that same COVID lab test that we used, if you look there in the red box on the left side of your screen, that direct site, and that concept, the concept that populates direct site, how that specimen in itself is a concept within the LOINC SNOMED collaboration. And similarly, this is happening, and this is being created within the IKM model using Tinker. So now we're looking at screenshots from the IKM environment that we affectionately call Comet. And what we're looking at the top of the screen, the device, we're defining that device, and that device becomes a concept in itself. And so we've got the vendor and we've got the type of device that it is. But what helps define that device is, if you look at the bottom of the screen, that red box for the device manufacturer, we're providing you with additional information on that device manufacturer that's aligned with that device. And similarly, with that same device, now I've got a different device here, but we're showing you that these results constraints are being defined as semantics within these different concepts for our in vitro device. And we can see here that it's defining what kind of results you have. So if you're doing that data aggregation, and the vendors are giving you different results for that same lab test, code, you can then align it from the different manufacturer and be able to understand what you're seeing. And as we continue here, so now we've got a SARS-CoV-2 test. And if you can see here in the middle screen in the red here, we've got our LOINC properties. And these are being defined for that in vitro device, along with the allowable results. And all of these are patterns, semantics that are populating the patterns that are associated with this device. And then this device will then be in our IKM model. The device will be associated with that lab test, and so you can get that additional information. And so here we have another viral panel, but this time it's for a non-COVID viral panel. And you can see that the allowable results are different from our previous lab results. And you can see how now we're kind of building on that, and we're defining those allowable lab results that are associated with that vendor. And all this information will then be associated with that LOINC SNOMED collaboration code. And so what this looks like and what we're building toward is eventually that the LOINC information, the SNOMED information, and additionally the LIDR information will reside together in one environment. And included in this environment is a reasoner function. And that reasoner function will allow us to create those hierarchies based on the axioms or those patterns and their associated semantics within our IKM environment. And so ultimately, we hope that this will improve lab data quality and improve the real world data that's entering these public health agencies that's being used for disease surveillance and also research. So now let's take a look at how we envision this being used in the real world. And this is how I started my presentation, with this exact same clinical statement. However, if we look at the right side of the screen there with that LOINC SNOMED collaboration, not only can we pull that LOINC SNOMED code, but then using the IKM model and Tinker, we can then apply what the device is, who the manufacturer was, what their allowable results are, and we can grab that additional information associated with this lab test, and that provides just richer real world data for that next pandemic that that we may face. So I talked about earlier about the HL7 Fire Connectathon, and this model was tested in both the May and September Connectathons. And we're excited to share that at the May Connectathon, we were able to demonstrate that making modifications and extension to SNOMED can be authored and without losing any data, and distributed as an incremental change set using the IKM model. We were then also able to demonstrate that various entities were able to ingest it and use these change sets, and also they were able to reconcile the modifications and the extensions to SNOMED that were made during this May Connectathon. So then in the September Connectathon, it got even better, because we were able to model new concepts within the IKM model, within the IKM environment, export these from one source and have another source import them without losing any data. In addition to not only these new concepts, but demonstrate that they were able to modify existing concepts and export those modifications from one source and import them into another. And then, so demonstrating the exchange of these incremental terminology revisions, what we call the change sets, between disparate entities was exciting for us, because we were able to demonstrate that no one lost any data. So we're getting close to a reality. So stay tuned for, as we continue to evolve this model, we will share the newest the newest with you at our next presentation. So at this time, I'd like to open it up to any questions.
Thank you very much, Christine, for your presentation. So does anyone here in the audience have any questions for Christine? Please raise your hands and we'll bring you the microphone. And there's one from Rob.
Welcome, everyone, today.
Hi, this is Rob Housem, and this is a great presentation. It's very interesting, and I've got multiple questions I'd like to follow up on. But I will stick with one thing, a comment and maybe a question. And first, I guess I'm one of the I'm an HL7 co-chair in orders and observations, and we're responsible for the for LIVID and standard, at least in fire, the fire implementation guide, and I'm one of the editors on that. And I just wanted to make maybe a clarification that the LIVID specification itself is open. It's not. It seemed, from what we were seeing on your presentation, you're kind of focusing on COVID and the those other particular conditions, but the LIVID itself really is not limited to any particular set. It's basically any in vitro diagnostic test that a manufacturer wants to provide guidance for is able to be done in the LIVID standard. So it's pretty open. But I don't know if you wanted to further comment on that and just see if you agree with that statement and I think that the idea is that LIVID can be used across a variety of things, and we hopefully expand that use and of course coordinating with LIDR and all that as you mentioned.
Oh, thank you, Rob. Yeah, no, I don't disagree with anything that you just say. And I know that Russ Ott, who's very active also in the HL7 community, was there at the Connectathon and could probably provide more information on that as well. And I know that Dr. Keith Campbell is there at the conference and can provide more information about that as well. But thank you for that comment.
So this is also Rob. One other question is I was curious about the idea of the concept and the pattern, and it wasn't entirely clear to me if those are entirely distinct notions. I mean, obviously you're using them in a distinct way, but in my mind, probably a pattern is a kind of a concept, and I wonder if you could amplify on that a little bit.
Yes, and I think when I kind of did the show and tell, the patterns are created as concepts themselves within Tinker. And then as they build the concepts, those patterns are pulled from the list of concepts to create the definition for the concept itself. So I think we're using concept multiple ways to describe multiple things. But just like SNOMED, all the different defining attributes for SNOMED are concepts themselves within the SNOMED terminology and within the hierarchies. The same thing with Tinker. That yes, each pattern is created as its own concept itself and has its own definition and axioms or defining attributes. And then when they're used to build a concept, then the patterns are also concepts themselves within Tinker. Hopefully I clarified that.
Thank you very much, Christine. But yeah, it was actually a similar question I had because it looks very, very good, but it's around when you come from a SNOMED perspective, it's really understanding the difference in the modeling of a pattern and a modeling of a clinical concept as we do it in SNOMED. So just clarifying that difference would be very, very helpful. Thank you.
Thank you. I made a note of that.
Thank you. So any other questions? All right. Thank you very much for joining us, Christine, and also attending here online and to answer these questions. Thank you very much.
Thank you.
Thank you. All right, so